Now let's switch to board. Now the very first step when you actually do manual routing, which we will understand today, is you should give generous time to component placement. Components shouldn't be placed very far apart and they shouldn't even be placed too close to each other. We'll see what happens in either case. So let's begin with our board. First we'll achieve our component placement. Ideal thing is to place your components first. Don't start placing in the right topmost corner. Always start placing generously from say middle and then follow towards the bottom left corner. Why we do this? The reason is the board is free to adjust from the top and the right. If you want to adjust your board size, you always adjust the board size from the top edge and the right edge. If you observe closely, you have your board origin in the bottom left corner. You should always avoid changing this origin. Let the origin be fixed. You change the board size if you want to reduce from the top and the right. So it's the same functionality. You select move tool, left click will move your component. With the component selected, right click achieves rotating the component. Okay, so now all my components are within the board area. I am at least sure that my board is not going to consume an area which is going to be bigger than this. I can now go ahead and reduce the board size a little bit. Don't shrink it too much. Let there be some extra space. It's okay. You can finish your route and then reduce it further. Now one more thing you should do is always try and reduce as many crosses, yellow crosses as you can before proceeding to route. Okay, when you have multiple resistors, LEDs, try to keep them as a bank. Say if I have two resistors out here, try to keep them in an horizontal or a vertical fashion together. It should look like a R bank, whereas preferably keep the LEDs together. Capacitors, you can place them at some distance, that's okay. But care must be taken that when you're placing components, you shouldn't place one here and the other here. This is not a good placement. What will eventually happen in this case is you'll have to route it all the way, which is not necessary, and your route is going to be too long unnecessarily. You will achieve a route which is this length. That will further lead to electrical issues like noise and loss as discussed earlier. So now I feel that I have achieved a compact placement. Let's move this a little more towards the left. So group, control, right click, and now I go ahead and reduce the board size a little further. Let's keep it a little towards right. We'll see why. Always use zoom to fit. That gives you a clear view of your circuit. Now only after you feel that I have achieved my placement, do rat's nest. It will find the shortest path. If you observe, I click on rat's nest. It just combines a few connections which it feels can be made even shorter. Okay, let's keep this here. Let's keep it here. So rat's nest will help you find the shortest route possible. It helps you reduce copper paths. So this is how our circuit is going to look. Okay, now let's begin routing. Let's try rat's nest again. Do we have anything? No. Select your route tool. Width should be at 0.024 and wire bend at style 1. You can zoom in further. This when you have an IC in your schematic, it will always be a good practice to use the show tool. Click on the IC pad, that's the pin pad or the pin number, and check the points which all are getting highlighted. If you observe, the green is highlighted. Let's see, this is pin number 8 of the IC, this is pin number 4. Let's compare with our schematic. Pin number 8, pin number 4 are connected to VCC. R1, one terminal of R1 should also be connected to VCC. Similarly, one terminal of R3 should also be connected to VCC, and all will get connected to pin number 1 of jumper. Let's see if this is satisfied. We have R3 one connection, pin number 8, pin number 4, R1, and one pin of the jumper. Okay. Similarly, let's verify ground. Let's check our schematic. We have ground connected to pin number 1 of IC, pin number 5 also connected to ground through a capacitor, one terminal of R2 going to ground, and one terminal of electrolytic, the negative negative terminal of electrolytic capacitor to ground. Let's verify this. So let's select pin number 1. This pin is pin number 1 of our IC. Pin number 1, negative terminal of electrolytic capacitor, one terminal of this capacitor, one terminal of R2, and finally the second pin of our jumper. Yes, this is correct. Finally, we have a cathode of LED 1 and anode of LED 2 connected to pin number 3 of our circuit, pin number 3 of our IC. So this is 1, 2 and 3, pin 3, cathode and anode, pin number 3, yes. Then we should have pin number 6, pin number 2, both connected to positive terminal of electrolytic capacitor and one terminal of R4. Let's verify this. If pin number 2 here, pin number 2, 3, 4, 5, pin number 6, positive terminal and R4, yes. R3 should be connected, one terminal of R3 should be connected to VCC, whereas the other should be connected to R4. R3 connected to R4 and pin number 7, whereas this gets connected to VCC. And finally, capacitor C2 should be connected to pin 5 and another terminal to ground. So yes, C2, pin number 5, the other terminal connected to ground. Yes, all our connections are in place. This is just to make sure all the connections in our schematic are reflected on our layout. That's the board file. Now when laying the routes of a circuit like this, which has more than 4-5 components, you cannot always say that, let's route the direct connections first and then we'll do the crisscrosses later. You have to anticipate connections, like you have to plan a little bit, like if I route this from here, maybe I won't be able to take this path from this side. If you observe here within the IC, from under the IC, we have too many crosses here. So we have to ensure that each of these connections, like this yellow wire, this one and this one, are all connected, but you have to plan and route them in a way that they don't cross. We cannot have a route like this. I cannot make it here and then I cannot overlap this connection. This is a wrong connection. If you observe a blue on blue, this is going to be a copper track, whereas this is also going to be a copper track. At this particular point, they are going to overlap and that creates a short circuit, that creates a short on the PCB board. We don't want to do that. Also, you can never have a route which goes like this. Here you are shorting all the 4 pins of an IC and you don't really want to do that. You can never have a route which goes like this, and then if I want a route from here, I cannot do it this way. A green and blue cannot overlap. A blue and blue cannot overlap. This is a blue and blue overlap. I cannot do this. This is going to create a short. Also, if I try to do this, it is going to create a short. A blue and green can only overlap in one case, where I know that I am supposed to connect this pin, this terminal of resistor to this particular pin of IC. That means I have to solder it over here. Obviously, these pads are going to appear as solder pads, but I want this connection to be made. Only in that case can I do this. If I want to route along through this thing, then in that case a green and blue cannot overlap. We'll see that later when we do it. So let's try and route the direct connections first, and then we might have to reroute. That's basically use the rip up tool if we need it. So if you remember, when we did our first layout, we discussed that when you begin a route, a yellow line constantly prompts where it has to be connected. Now if I drag this yellow line from above the circuit over here, it still points that this highlighted pad is where it has to be connected. If I move further, it will show the next possible connection. Now it shows the green highlight. It shows that now this particular wire can be connected to the negative terminal of polarized capacitor. If I rotate it further, if I come here, it will now say I can connect it to to the other terminal of our 2 resistor. So you have to keep a watch on the yellow prompt. Like when you start a route, just keep observing like where is the yellow wire prompting. Okay, so this is one done. See, if I want to make a connection from here, this blue and green overlap out here is going to create a short, because this copper is going to overlap with the solder pad of this IC, which is not a good practice. It is not allowed. Let's check where is this getting connected. Okay, now to achieve this I can route it from outside. I can take it from here. Okay, so this is achieved. Now the only remaining connection to complete this path is this one. Okay, so this circuit is done. See, now here you have to be careful in such cases. You have to carefully see where the yellow wire is prompting. If you don't observe it carefully, you might as well connect it here by mistake, but no, it's actually connecting this particular pin, that's pin 1, 2 and 3, to the cathode of LED. So you have to be careful. Also, you must not have any 90-degree bends in your layout. 90-degree bend tracks they tend to come off during the process. Also, they cause electrical disturbance. They are the cause of noise in your circuit. So avoid 90-degree bends. Always use smoother bends. Okay, now let's observe what connections are left. One is where we need to connect 1, 2, 3 and 4. That's pin number 2, pin number 6, capacitor and the resistor. And also we have to connect this capacitor to pin number 5 of our IC. Let's just figure out how will we do this. One thing is for sure, that I cannot achieve any connections from under the IC now. I cannot do this, right? There will be a blue and blue overlap which will result in a short. I cannot route this one from here. Neither can I route this one like this. Again, it will create a short. So we'll have to think about routing it from somewhere outside. Maybe you have to drag it all the way from here and then drag this one also from outside somewhere. So let's just quickly try which one suits our achieve this one first. With practice, you will understand that adjusting your zoom dynamically is going to really help. If you observe, when you are routing without releasing your tool, you can scroll in and scroll out, and that achieves the zoom. So with practice you will achieve that. It requires some practice on Eagle itself. Now let's try this one. If we observe, now if you realize, we don't really have any space to take this one from anywhere. I cannot do this, neither can I do this, neither can I come from here. So we will have to rip up our connections and try some other route. It's a good practice to always do rat's nest after you do a rip up action. Now let's try the inner connection first. Now care must be taken, I cannot do it this way. A green and a blue overlap is going to create a short. So you have to keep it safe in between. Now when you have to lay these routes from quite outside of the circuit, care must be taken that you are not dragging it way outside the circuit. It has to be within the dimensions at least. It shouldn't be too spread out. You cannot route this from here. Say it's overlapping, so I'll route it from here and then take it inside. No, that's not a good idea. You're wasting area. You're wasting copper on your circuit. So that shouldn't be done. Okay, let's see if we take it from here, or maybe we take it from, okay, let's do this. Let's take it from here. Just observe where the yellow wire is prompting. At this particular point, it says it has to be connected to one terminal of R4. If I drag it in a little further, it says it can also be connected to pin number 6 of the IC. Now if I release this route here and drag it like this, okay, this achieves a connection and it leaves me, I think, enough space to route this from here. So let's try routing this. we should have done this one first. So this has to be connected here, and there is one more route left, which is this pin. If you observe this particular pin of the IC with this positive terminal of our capacitor. So let's do this from here. If you observe closely, it is pin number 6 and not pin number 5. Now if you realize, I have to connect it from under the IC, from under the pads. So this green and blue are going to cause an overlap over here, pin number 5 and blue. So I will require to rip up this particular path and route it again. So yes, you can obviously be generous when laying the routes, but you cannot be over generous. You have to make sure you are not using up too much area so that the other routes cannot be done. You have to route it judiciously. You just cannot go on. Okay, let's do it this way. Okay, this one, and finally let's complete this one. If you now realize, it has given you enough space to drag this one from under the resistor and to your pad, to your pin. Now if you realize you have enough free space around your circuit, now you can move this group, adjust it such a way that it is on the bottom left corner. It shouldn't touch your white borders, but it should be as close as possible in the left corner. Then you can further reduce your board size. This particular circuit can be made even more compact, but since it's our first project with bigger circuits, we've achieved a considerably compact board size, so don't worry about that. With practice, you can analyze more complex circuits. You can try rerouting the layout and then route it again and try different combinations, different placements, and see if you can reduce the board size further. Now let's use the text tool and give the name as flasher, and let's see if it fits here. Yes, it fits. You can also give your name here, XYZ. I can also give the date, and here I have the date. So like we add an attribute to our schematic, attributes can also be added onto your board file using the text tool. If you observe, your text is going to appear exactly a mirror image. That's because this is the bottom side of your PCB. It is where your solder pads are going to appear. So your front is actually behind the screen if you observe. Just try to imagine that this, what you're looking at, is the bottom side of your board where you will be actually able to solder your components, whereas the front or the top of this particular board is other side of the screen. Just try to imagine that, and we'll make this concepts a little more clear. Let's run the DRC first. Okay, let's do the rat's nest first. It's very important. Rat's nest. Okay, we have all the shortest routes possible achieved. Okay, now let's run the DRC. Check. Yes, we do have a dimension error and some font error. We'll see how to resolve that. Now dimension is here. Now this particular track is very close to our board boundary. It's trying to tell you that if the routing is placed like this track might just not get printed on the PCB board. So let's move this out of here. can select your group, select the move tool, control plus right click is going to achieve your move group action. Okay, now let's run DRC again. Okay, the dimension errors are gone. Let's see what this vector font means. Now Eagle, the library, has certain fonts which it recognizes, the others it doesn't. It's not an editor for that, say. So you are permitted to use only select fonts which the Eagle compiler or the software supports. So you right click on this origin next to your text, check properties, and then you have a tab which reads font. Change that from proportional to vector and say okay. Similarly for the other one, properties, font, vector. Okay, you see that style has changed. So these are the fonts which can only be printed when these boards go into manufacturing, and these printers are not like our document printers, so you need to stick to certain style of fonts. Let's do the DRC check again, and now it says width, which means that this particular text that we have entered is too thin to get printed on our PCB board. To change that, now you have to go ahead, right click, properties, and there is another tab under the size which reads ratio. Now this is trial and error. You have to try and change the ratio until your DRC error is verified. So let's keep the ratio to 10 and check if it's okay. Okay, the font has become a little thicker. Check, no, it's still less. So let's increase the ratio to 15 and check. Okay, DRC check. Yes, 15 is going to work. You see the thickness of font now, it's very close to the thickness of our tracks. Okay, DRC check. If you observe, now we have no errors. Let's say zoom to fit, and this is how our final board file looks. This circuit can be further made compact. Now the dimensions are 1.75 by 1.6. This can be easily fit into a 1.2 by 1.2. So try and achieve that. You can place these components a little closer to each other. This is a skill that you will acquire only with practice. So this is it with our complex design, which is we've successfully made a flasher schematic and achieved a decently compact board size. In the next lecture, we'll be looking at how exactly will you achieve a PCB board out of this layout. That's a physical PCB board I'm talking now. So in the next lecture we'll discuss that. Until then, thank you.